This video is on compound probability formulas. All right, this is another way for us to look at conditional probability, okay, but in a compound setting. Um, so anyway, we have this formula that we've learned before that says the probability of B given A can be found by taking the probability of A and B divided by the probability of A. Okay, so the probability of B given A. So notice the given statement, that's still our denominator. But now what they're going to do is they're going to say the numerator, or your success in the probability, can be found by looking at it as an and type of statement. All right. So let's take a look at how this is being used. For example, in a study designed to test the effectiveness of a new drug, half the volunteers received the drug. Not a bad idea to highlight things as we're going through. The other half of the volunteers, the other half received a placebo, which is a tablet or pill containing no medication. The probability of a volunteer receiving the drug and getting well was 45%. They want us to figure out what's the probability of somebody getting well given that they received the drug. So the probability that we're trying to calculate here is getting well given that they received the drug. All right. Now, according to our formula that we just learned, the numerator, or success in our probability, is all those that got well and received the drug, or received the drug and got well. Now, that was 45%. And our denominator would be all of those that received the drug. Remember, we have this conditional statement. All right, the given part. Those that received the drug, that was 50%. All right, where did I have that? Half to receive the drug. So that's 50%. I simplify this fraction. I can look at it as 45 over 50. I can look at it as 0.45 divided by 0.5. Either way, when you do it, you get 90%. All right. How about the probability of volunteers? So we're using the same scenario as up above, but now it's the probability of receiving a placebo and having his or her health improve was 20%. Placebo and having the health improve was 20%. They want us to figure out what is the conditional probability of a volunteer's health improving given that they got the placebo. All right. So I would write this as probability of health improvement. How about we call that getting well given that they took the placebo. All right. Success is going to be you got well and took the placebo, or you took the placebo and got well. Remember, that's health improving. So that would be 20%. And then our total here is the total that took the placebo, which up here it says half took the placebo, so that'd be 50%. If I take 20% divided by 50%, that simplifies to 40%. All right. The next statement says that conditional probabilities are usually not reversible. That means most of the time, the probability of A given B will not be the same as the probability of B given A. So let's take a look and compare these conditional probabilities and see if they are the same or are not the same. So this first part says, in a survey of pet owners, 45% own a dog, 17 own a cat, and 12 hold both a dog and a cat, own both a dog and a cat. What's the probability that a dog owner also owns a cat? All right, a dog owner, that's our given. All right, so what we want to do for this first one is what is the probability that you have a cat given that you're a dog owner. All right, so sometimes you got to play with the words a little bit to figure out which is the given in this compound statement. Okay, so I'm looking for the probability of cat and dog, which means they would own both. That's 12%. And we're going to divide that by the probability of the given, which is the probability of a dog, or 45%. Now, I went ahead before we did the video and I figured all these out. 12 divided by 45 is going to simplify to 26 plus 0.7%. The second question says, what's the conditional probability that a cat owner also owns a dog? So this is the probability of a dog given that you own a cat. All right? Again, dog given cat or cat given dog, doesn't matter. They're talking about dog and cat for our success. So I've still got 12% for my numerator. And this given is that they own a cat, so that would be 27%. 12% divided by 27%, that would give me 44.4%. And as you can see, if I simply switch the order here, I get different results. That's why we got to be so cautious and paying close attention to what the given is. I'm not going to get the same results. The same survey showed that 5% of the pet owners own a dog, a cat, and at least one other kind of pet. So they got at least 3 pets. Part A here says, what's the probability that a pet owner owns a cat and some other type of pet given that they own a dog? So this is going to be the probability, I'm going to call it, of a cat plus given that they own a dog. All right. So this is saying a cat and another pet and a dog would be success. That's 5%. The probability of a dog from the previous information was 45%. And if I simplify this, I get 11.1%. Part B here says, what's the probability that they own a dog and some other kind of pet, a dog and some other kind of pet, given that they own a cat? So I'm going to say that this is the probability of dog plus given that they own a cat. So the probability of a dog and some other animal and a cat, that would be 5%. And then the probability of a cat, up above we learn, is 27%. And if I simplify this, I end up with 18.5%. Again, this is done to show you guys that the order in which you write things and calculate this probability is very important. Now, the last thing we want to talk about is this idea of using a tree diagram in a conditional type of setting. So, for example, one way that I like to do these is using a tree diagram. And what I'm going to do with this tree diagram is try to organize all this information and data that they give us. Okay? It says a college reported the following based on their graduation data. Okay? I notice all the data is talking about freshmen. So I'm going to start off by kind of saying, all right, if I've got freshmen, I know that 70% of them attended public school. So I'm going to make 2 branches here. I know that they either attended public school or something else. All right? And I know that that would be 70%. Now, if 70% attended public school, that means that the other would have to be 30% because it has to be 100% of the freshmen. All right? Now, it says of those that attended public schools, 60% graduated within 5 years. Okay? 60% graduated within 5 years. So we're going to take this data and now say you either graduated or you didn't. within 5 years. Again, they said 60% graduated within 5 years, which means 40% did not. It says 80% of other freshmen graduated within 5 years. So the other that graduated versus not graduating would be 80% and 20%. All right? And they say what percent of the freshmen graduated within 5 years? All right? So what I'm looking for is freshmen that went to public and graduated, or freshmen that went to other and graduated. And I have to take those and kind of put them together. All right? So the way that I'm looking at this is I would say, what is the probability of public and grad? And I'm going to add to that the probability of other and grad. And the way that we are going to figure this out, and kind of gives it away, we're going to multiply these probabilities. So what do I know? I know the number that went to public was 70%, and those that graduated was 60%. I know the probability that you went to other was 30%, and graduated was 80%. So then if I take those probabilities, let's see, 70 times 60, that would be 42%. And 30 times 80, that would be 24%. So if I now add those together, I get 66% would be my final answer to this scenario. All right? Sometimes the tree diagrams, guys, take a lot of practice to kind of get used to. So be prepared on Math Excel. You might have some challenges if there's any tree diagram type of questions. Let's try one more. So I got a soccer team that wins 65% of its games on muddy field and 30% of their games on dry fields. Okay? So what do I know? I know they're playing games. And when they play games, the field is either dry or the field is muddy. All right, when the field is dry, they either win or lose. And if the field is muddy, they either win or lose. And now I'm going to kind of put my information that they gave me from this scenario up here. All right, so they say that they win 65% of the games on muddy fields. So I go to muddy. And then I know for muddy, they win 65%, which means that they lose 35%. Remember, they have to add up to 100%. They say that they win 30% of their games on dry fields. So they're going to win 30%, which means they lose 70%. All right? It says the probability of the field being muddy for their next game is 70%. So what does that tell me? That tells me that muddy is 70% and dry, therefore, would have to be 30%. All right? They want to figure out the probability that the team's going to win their next game. All right? So I'm going to take this information. This is the probability of they want to win. Okay? So the probability of dry and win added to the probability of muddy and win is what they're asking us to find. Now the probability of dry and win, so that's going to be 30% times 30%. Probability of dry is 30%. Probability of win when it's dry would also be another 30%. Okay. Probability of mud and wind would be 70% times 65%. So this would be 9% plus 70 times 65. That's 45.5%. Add those two together and I get 54.5% chance of winning. So better than half potential of winning. All right. Hope this helps. Let me know if you guys have any questions.